Hi everyone. How are you? Hi Asher. You know what? I was making this screencast and I found these two questions that are so great before we move on. Go ahead and open your book to page 406. Look at number 61 and look at number 62. If you look at those, 61 says, and pause me if you're kind of just finding your book and flipping it open here. But it says, if b is bigger than 1 and f of x equals negative log base b of x, which of the following pictures above, figure 1, 2, 3, 4, 5, 6, could viably be the graph of this? And then 62 asks a similar question with f of x being b to the x plus 1, and they tell you here where b is between 0 and 1. Which of the figures, figure 1, 2, 3, 4, 5, 6, could viably be described here? Now, I'm going to start working through these two questions right now, but I think what I'd like you to do is to try it on your own and then come back and talk to me if you want to, all right? So, all right, number 61. Well, here, this is such a great question in light of our just brain thought today. Listen, if this was f of x equals log base b of x, let's just forget this negative for a second. We know a general log function, it has this picture, right, everyone? It has something like this. We know it looks something like, that, right? Okay. What does this negative do as far as transformations? Indeed, this right here, this negative would reflect this graph over the x-axis. So then really we're looking at something like, maybe something like that, right? And there'd still be a vertical asymptote. So which of those pictures, figure 1, 2, 3, 4, 5, 6, which of those could be the graph in number 61? Indeed. Figure 5, or figure V, right? 5 Roman numerals. This could be figure 5, right? How great is that? Outstanding. This one, look at this one. F of x equals b to the x plus 1. Oh, where b is between 0 and 1. What does that make this? What kind of function? Exponential function, but is it exponential growth or decay? It is exponential decay because this base is less than 1. And we know an exponential decay function generally looks like, looks something like this, right? And with a horizontal asymptote right here, right? There's a plus 1 here though. So that means this general exponential decay function would be moved up 1. So really this function would look something like this, something like roughly like that. Now when I look at the possible graphs over there that are offered to me, 1, 2, 3, 4, 5, 6, which of those figures could, conceivably describe f of x? It is figure 4, or IV. Yeah, love that. Love that one. Those are really great questions, particularly in light of our spring break thaw. The other one is 452, number 5. Go there with me. Yes, do you see how I'm kind of straddling the trig as well as we're reviewing? 452, number 5. Let's read it with me. And pause me if you're kind of flipping. It says, in exercises 1 through 6, find sine of t, cosine of t, and tangent of t, when the terminal side of an angle of t radians passes through the given point. So in this question, they're calling t is the angle, right? T is the angle, and the terminal side, it says number 5, the terminal side passes through the point radical 3, 10. Holy blast from the past. Oh my goodness, angle on a coordinate plane, and it says, unless stated otherwise, all angles are in standard position. What does that mean, an angle in standard position? Oh, right, an angle in standard position means the initial side is the positive x-axis, radical 3, 10. Oh, radical 3, negative 10. Silly Miss Yam. Okay, that point is, let's see, radical 3, negative 10. Let's just kind of, radical 3 is between like okay, so this point here is radical 3, negative 10. Let's see, what direction does the angle open in? It doesn't say. It says find sine of t, cos of t, and tan of t when the terminal side of an angle. So as long as the angle's in standard position, the terminal side has to pass through this point. So my angle looks like this. Now my first question to you is, I'm going to label the angle t. Now you have two choices, because it didn't say that the angle has to open positively, right? That would be angle t. Maybe the angle opens negatively, in which case the angle would be this way, right? That angle t. So regardless of what t is, maybe t is the gray angle or t is the green angle. Here's my question, boys and girls. Whether t is the green angle or the gray angle, do you see how green angle t and gray angle t, those two angles are coterminal. Yes, they both have the same terminal side. That means when I go over here and find the sine of angle t, the cosine of angle t, and the tangent of angle t, if angles are coterminal, they will have the same sine, cos, tan, cosecant, secant, cotangent. So however you want to label your angle t, it doesn't matter. However, how do we find the sine of angle t? How do we do a right triangle? We're not in quadrant 1. Oh, right. You have to, okay, let's go over here, find this point. We're going to drop an altitude to which axis, everyone? Don't you dare say the y-axis. Don't you dare. Don't you dare. Don't you dare. It's down to the x-axis. Here we go. There's my right triangle. Look at that. And my right angle is right here. Okay. Now we know some side lengths here. This side length is radical 3, right? This side length here is, negative 10. Oh, how do we find the hypotenuse? A squared plus b squared equals c squared. So I'm going to go over here and find the hypotenuse. I'll call it h. So h squared equals radical 3 squared plus negative 10 squared, right? So h squared equals 3 plus 100. So h squared equals 103. So h equals root 103. And without a calculator, I'm just going to leave it alone. I'm going to leave it alone. Okay? Now, notice something here. That is, okay, be careful. That length is root 103. Now, do I have everything we need to find sine t, cos t, and tan t? And you know what I always do, boys and girls? I always take care of the positive negative. We're in quadrant 4. Cos is positive, but otherwise sine and tangent are negative. Okay? Sine of angle t. Sine is opposite over hypotenuse. And again, we treat the angle as, remember, it's always the reference angle right here. Or it would have been the green angle t, reference angle. Opposite over hypotenuse. 10 over root 103, or negative 10 over root 103. Okay? Cosine of t is going to be radical 3 over root 103. I should have skipped a line. Tangent of t is going to be negative 10 over radical 3. And do we ever leave radicals in the denominator? Oh, for heaven's sakes, no. So I'm going to multiply by radical 103 over radical 103. I get negative 10 root 103 over 103. That's the sine of angle t. And then I get, square root of 309 all over 103. Okay. And then over here I get negative 10 root 3 over 3 after I simplify or rationalize all the denominators. Everyone okay with me? Okay. All right. Very good. Very good. Very good. That was a little bit of a blast from the past, huh? All right. You know what I want you to do right now? Go ahead. While we're on this page, I just happened to look here. You know what? Might as well just kind of, press through the agony. Go ahead right there. I'm looking at it right now. 452. Go ahead and try your hand at numbers 31 through 47 odd. Look at all those. Oh my goodness. Find the exact value of the sine, cosine, and tangent of each one. Oh, that's going to take you forever, everyone. You know what? Forget that. Let's just do a couple. Let's just do, how about I assign 31, 35, 31, 35, 43, 47. All right? And the sine of that angle, and those angles are in radians. Oh, don't you love that? Don't you love that? Okay. And I think I'm going to do this. You know, I'm thinking about something, and I kind of feel like I just want to give you a homework night where you're just kind of fortifying those things that you've done already. And boy, are you boys and girls in great, great, great shape. I think I'm going to have you do this. I'll do this one. How about have this for homework, and then also let's just kind of do might as well, a review of some applications of exponential functions, okay? So let's see, page 407, number 73, okay? Let's see. 77. Oh my, compound interest. I like that. And 78. How about that? I think that's good. That's good for homework. All right. Great job today. Great seeing you, and I will see you tomorrow. Goodbye.